good day. It's a sunny day to tackle about some mathematics topics. My name is Jay de la Cruz, your student in Mathematics in the Modern World, under code of G692 Rooms 206. Now I'm going to discuss about my topic, which is Cramér'S B correlation. It's interesting since I'm going to define what Cramér'S B is and how can we get an answer by using the formula of Cramér'S B. Now, without further ado, let's start. Let's define first the Cramér'S B. Cramér'S B, or sometimes called as Cramér'S pi, or this C, is a measure between two nominal variables. Okay, for clarification, nominal variables is a level of measurements that describe the information within the value assigned to the variables. It is based on person chi-squared and published by Harold Cramer in the year of 1946. Now you may ask, who is Harold Cramer? He was known because of this Cramér'S B in his theories. He is a Swedish mathematician and statistician, specializing in mathematical statistics and probabilistic number theory. And he was described as one of the giants of statistical theory by John Hickman. Now remember, this is a Cramér'S pi. This symbol, this is a mean square canonical correlation between the variables. In the case of 2 by 2 contingency table, Cramér'S B is equal to the absolute value of pi coefficient. So to sum it up, Cramér'S B is a measure that does indicate the strength of the association in Cramér'S B. The formula is C square root of pi squared over n is 1 and close parentheses. This is the Cramér'S B and symbolizes as the sample size. The K is the lesser number. Categories of either variable. So, how does Cramér'S B work? Cramér'S B is a way of calculating correlations in tables which have more than 2 by 2 rows and columns. So, Cramér'S B is defined in, you can see it in tables and rows, in by 2 rows, and it is used as post-test to determine strengths of association after chi-squared has determined significance. So what is the difference of chi-squared and Cramér'S B? With chi-squared and Cramér'S B, we compare the observed frequencies in the cells of contingency table with what we would expect to see if two variables are independent. So basically, chi-squared is a statistical significance. Cramér'S B is a measure of substantive significance. So, why chi-squared value is significant? In general, a p-value of 0.05 or greater is considered critical. Anything less means the deviation are significant and the hypothesis being tested must be rejected. When conducting a chi-square test, this is the number of individuals anticipated for a particular phenotypic class based upon ratios from a hypothesis. Now let's proceed to the word problems and let's try our best to get the answers using the Cramér'S formula. So I'm gonna attach the photo here beside me. So I'm gonna cite the problem. Here's June 1969 examined the association between the intimacy of a boy's communication with his father and the number of the boy's friends who have been picked up by the police. First, she hypothesized that intimate communication with fathers would reduce the number of delinquent friends. The table below summarizes the Hurst-G analysis. The obtained chi-squared is 28.77. So find the Cramér'S speed. Here, you can see the formula of Cramér'S speed. Now, 28.77 is our chi-squared. The n is a known, and we have 3 here because we have 3 rows and 3 columns. So here, to find the n, we must add all of this. So we get the obtained of, we can obtain the 910. Yes. We have 910. To get the Cramér'S speed, just plug in the statistics to figure it out. So 910 times 3 minus 1 is 180/20. So the bottom line is 180/20. And the B is, I think the top is 20.67. Then divide then take the square, then we get the Cramér'S speed. So we divide then, we get the answer of 0.126. Now, so measure of association is a measure by their strengths to their categories. So we have weak, 0.29. Moderate, we have 3 to 0.29. Then strong, we have 6, 1. Measure of association should never over 1. In this sense, our Cramér'S speed is weak, as you can see, 0.126. So belongs to weak. Then it makes sense because the hypothesis says that boys who has better communication has less dealing with the adequate friends. Now for the second problem, we have 2 by 3 table. This is 2 by 3 table. Yes. Suppose we want to know if there is an association between eye color and gender, so we surveyed 50 individuals and obtained the following results. So this is the results. We can use the following code in R to calculate Cramér'S speed for these 2 variables. So Cramér'S speed, to sum it up, Cramér'S speed turns out to be 0.1671. The degree of freedom would be calculated as degree of freedom. So this is the degree of freedom. Degree, open parentheses, rows, then columns. Minus 1. So, how many rows do we have? We have 2 rows. 2 minus BF is 1. Referring to the table of above, we can see that Cramér'S beat is 0.1671 and degrees of freedom is 1. It indicates the small or weak association between eye color and gender. So, if we go back to our previews, the weak is 0.29. So, hindi siya dapat. So, bilang siya sa weak. So, for the second example, suppose we want to know if there is an association between eye color and political party preference. So, we surveyed 50 individuals and obtained this following result. In this, we also use code NAR to calculate the Cramér'S beat. So, sum it also this. Cramér'S beat turns out to be 0.246. The degree of freedom would be calculated as DF3 rows along the DF3 table above, we can see that Cramér'S beat is 0.246 and degrees of freedom is 2. It indicates a medium or moderate association between eye color and political party preference. So for the next example, a scientist wants to know if music preference is related to study major. He has 200 students, resulting in the contingency table shown below. So these round frequencies, as you can see, are just we need for all sort of computation, but they don't show much of a pattern. The association of any between the variables is easier to see if we inspect raw percentages instead of raw frequencies. Things become even clearer if we visualize our percentages in snap bar charts. So for the next, I'm going to show the next photo. So in our first example, the variables are perfectly independent. X or chi-squared equals 0. According to our formula, chi-squared equals 0 implies that Cramér'S beat is also 0. Cramér'S beat is also 0. This means that music preference does not say anything about study major. The associated table and chart make this clear. Note that the frequency distribution of study major is identical in each music preference group. If you'd like to predict somebody's study major, knowing his music preference does not help us the least little bit. Our best guess is always law or the others. So for the second sample of 200 students shown a different pattern. The row percentages are shown below. This table shows some association between music preference and study major. The frequency distribution of studies are different for music preference group. For instance, 60% of all students prefer pop music to study psychology. Those who prefer classical music mostly study law. The chart below visualizes our table. Note that music preference says quite a bit about study major. Knowing the former helps a lot in predicting the latter. For this data, chi-squared is equal to 130. Our sample size set is 100. Add all the numbers, we get the 200. And the variables between 4 and 5 category. So P equals 3. It follows that pi squared 113 the N and the E 0.1 is equal to 0.43, which is substantial but not super high since Cramér'S V has a maximum value of 1. So he also this belong also in B category. So for the last sample, the third and last sample of students, music preference and study major are perfectly associated. The table and chart below show the row percentages. If we know student music preference, we know this study major with certainty. This implies that our variables are perfectly associated. Do notice, however, that it doesn't work the other way around. We can tell with certainty someone's music preference from his study major, but this is not necessarily perfect association. So, for the next, with the pi squared up, it's u, pi squared equal to 600, to add it all, 200, and say 1, which is the very highest possible volume for Cramér'S V, so it belongs to this ground category. So that's all the word problem. So I hope you did learn something in this video, and thank you.